Hi my dear students, I noticed that some of you were absent, so this video for those who are absent, so I don't like actually to leave anyone behind, so I hope this video will be useful. I hope you will make this video useful and you watch it in the end. Okay, so this video is about angle types, okay? And the first one is an acute angle. An acute angle is something, of course, an angle in math. An angle in math, or more specifically in geometry, it's a region of space determined by the intersection of two rays. Okay, so this is the ray. It's like the ray of the sun, of course, sunshine. Okay, so this region here called an angle. Okay, so we need to measure this angle, and this point across is called vertex. So vertex in French, le sommet. Okay, and those two rays here called arms. Okay, demi-droite ray intersection, okay, of the two rays find this interesting region of space, in this region called an angle. Okay, now we want to talk about angle types. The first one, as I said, is acute angle, so which is something that looks, let's say, something like this. Okay, and it's less than 90 degree. Okay, and or between 0 degree and 90 degree. Okay, so it can be something like this, or more smaller, or let's say, for example, 45, and so on. So the second type is the right angle. Okay, so the right angle is an angle, and we use this square box, okay, as an arc to say and prove that it's a right angle, okay, which measures exactly 90 degree. Okay, and of course you can draw something bigger than the right angle, which is something that looks like this. Okay, so this called not acute angle is something less than 90. Okay, so this called obtuse angle, okay, which is greater than 90 degree, but less than 180. Okay, so something that looks like this, or like this, or even something closer than a straight line. Okay, and of course we can talk about straight angle. Okay, that's very obvious, which is an angle on a straight line, okay, which measures exactly 180. Okay, and we can talk about something bigger than the straight line, okay, which is something that looks like, let's say, something like this, okay, which is bigger than 180, let's say 200 degree. Okay, and you can keep moving like this. So this is called circle angle, which measures exact, we can call it like that, an angle around a single point. Okay, 360. Okay, which is a full turn. Okay, so this one here called reflex angle. Okay, something that looks like this. So it's bigger than straight line, straight angle. Okay, so it's between 180 and 360. Now let's move to properties, which means assumptions or sentences that we use to justify our calculations. Okay, as I said, we never start a mathematical mathematical proof by math. You start with a theorem or some words, and then you need to justify your calculations. So how? So you need properties or theorems. Okay, so the first property, and it's an interesting one, and it's very obvious, is that if you have, for example, two angles on a straight line, let's say, for example, an angle A, and here we have an angle B, okay, so the sum of the two is, well, angle A and angle B gives us this straight angle here, so it's 180. Okay, let's say, for example, that this angle measures, for example, 60 degrees, and I'm looking for this angle A, so A equals to 180 minus 60, okay, which is 120. Okay, and we will talk about the proof structures that you need to know, because we can just write A equals 180 minus 60, because this is not how we write proofs in math. You need to justify this. You need to set the property you are using to justify your calculations. Okay, fine. So this is the first property, angles on a straight. So you need to remember this: angles on a straight line add up to 180. The sum of angles on a straight line add up to 180. Okay, so the second property is, let's say that we have two lines across, intersection de deux droites. Okay, so vertically opposite angles are equal. So we have A equals B, and also let's say here X and here W, so the angle X is equal to W. Okay, let's say, for example, we have two lines across, and I want to calculate the angle A, and for example here we have 45, so we say that A equals to 45 degrees, and the only reason is vertically opposite angles are good, are equal, so you need to say that. Okay, so whatever you hear, work out the missing or unknown angles and give a reason. So the reason is this: vertically opposite angles are equal. And please, we are talking about two lines across, okay, not something like this. Okay, so for example, the angle, for example, X, it's not it's obtuse, but this angle here, it looks like a right or acute angle, so you can say that X equals to M, because we don't have vertically opposite angles. We need to have something that looks exactly like this. Okay, two lines across. Okay, and if that's true, the property is correct, then you can use it. Okay, and the last property is angles around a point. Okay, and angles around a point, which is called a central point, that make, of course, a full circle, add up to 360. Okay, so let's say, for example, we have here a point, something that looks like this. So we have, for example, here 130, and here, for example, 60. Here, for example, let's say 80 degree, of course. And I am looking for this angle. So all you need to do is X equals 360 minus the sum of remaining angles, which is 130 plus 60 plus 80. Okay, so you calculate the sum, okay, of the three angles here, and you subtract the result from 360, and you will come up with the measure of the angle x. Okay, so this is all you need to know about angles and properties we use to justify our calculations. So whatever you hear, give a reason or prove your calculations. You mention the property, you make sure that the property is valid, and then you mention this property you're using. Okay, so this video for my dear students who are absent, so I don't like, as I said, to leave anyone behind. So I hope this video is useful, and I will share another video about triangles, okay, and their properties, so we can move to problem solving. Okay, and thank you.